Hope you're doing well and safe. I'm Neha, and I have Shubham with me. A little bit about myself. We are the co-founders of Hybrid KTS, and we have been into data and platform engineering for organizations like FARI, Lenskart, AWS, and CERN. Today, we're going to talk about how to make deployments of your machine learning applications reliable by enabling automated rollbacks in Kubernetes. Please do put up any questions or thoughts. We'll definitely be taking up some questions towards at the end of the session. By the end of this talk, you'll have insights on reducing downtime and user impact while deploying your machine learning applications faster than before, with reduced maintenance and cost and effort too. So we'll always wanted to deploy our machine learning model as soon as possible so that we can iterate faster. However, disasters happen and they come in many shapes and forms. For example, configuration problems, latency issues, crashes, decreased accuracies, right? So the challenges revolve around when you deploy your machine learning models, it takes a lot of manual effort to do production sanity testing to see if everything looks fine within logs and other metrics like latencies, error rates, etc. So if you choose to go with automated scripts, which contains log regexes of your machine learning applications or validation on your network metric data, it will come with a lot of maintenance of those scripts and it becomes boring, right? So other problems lie around performance of machine learning models being unpredictable, sometimes which requires quick rollbacks, and automation on Kubernetes can be hard sometimes. So how do you verify sanity of your machine learning deployments at scale? By introducing progressive delivery without any custom scripts. So for those who are not aware, progressive delivery is known for increasing deployment speed, system stability, and cross-team collaboration. Let's take an example. Here's a canary deployment happening on your Kubernetes cluster, which is a pattern for rolling out releases to a subset of users or servers. The idea is to first deploy the change to a small subset of users and then test it via hybrid KTS logs or performance metrics, and then roll the changes out to the rest of the users. Now, you might be curious what would happen in case of a buggy machine learning model being released. Let's say if I roll out a faulty release, the canary deployment will serve as an early warning indicator with less impact on downtime. And if the canary deployment fails, the hybrid KTS agent will flag and roll back. So point to note here is the user impact was highly reduced to 40% in this case, and the rollback decision was instant. So how do you think this automation will work behind the scenes? By comparing logs and metric data of new and old deployments in real time, which otherwise becomes difficult to monitor at scale when you have thousands of logs per minute and so many metrics to track, right? So this is how things would work on the backend. There would be a service mesh, which will help in splitting the traffic to your new and old deployment, a hybrid KTS agent that would be syncing up on logs and metric data to see if we can release the machine learning model to the next subset of users. Now, I would like to call upon Shubham to show a quick demo of how you can enable this setup within a few minutes. Shubham, over to you.
Now, for the demo, what we have is we're going to use the CLI to access Kubernetes. Here we have a new Kubernetes cluster with a test namespace. It's going to have a test application as well as a load tester. This test application is going to be your ML application right now, your current state, however you're doing deployments on Kubernetes. Here we have the hybrid KTS dashboard to interact with the API. This is the documentation I'm going to follow. It has all of the steps I'm going to show you in this demo, and you can check this out at docs.hybridkts.tech. And this is linked to the dashboard to see around what's happening at the network layer. It'll allow us to see the traffic split, the success rate, and all of those things. Perfect. So the first step here is going to be to add the agent to our cluster. For that, we'll just name this Hasgeek demo. And just copy all of these commands. So now what this command is going to do is it's going to install the hybrid Kubernetes agent to my cluster, and it will allow hybrid allow us to send in logs and metric data during our deployment. So while this is done, while the agent becomes online, I can quickly copy the API key. So the API key is here for security purpose. It is separate for each and every cluster. So copy that, and I have this canary file, which has this basically Flagger canary file, and it has the canary configuration that we're going to follow. So I've pasted the API key. All other configuration is in check. And just apply this file. Meanwhile, I can check if my agent is online. Yeah, agent is online. So that's basically all of the initial setup required. At Linkerd, now we can see there's this new deployment created. This test app primary is going to be the primary folder of a machine learning model. And the older deployment is going to use for the canary. You can see all that here. So if I go to deployments, you're able to see all of that available. It takes a few minutes to set up everything. To see the progress, I can also just describe the canary object. So here we were able to see that it's currently rolling out, and it's in the syncing state. Meanwhile, we can also see the traffic split. Okay, so they're not created the traffic split configuration yet. So by end of this process, we'll have 2 deployments and 2 extra services. One will be an Apex service. So we have, now this is created. So we have test app as the Apex service. And this is split into 2 leaf services, which are just created. Right now, the traffic split is 0 and 100. So all of the traffic is going to my primary application, which is the older version. Now, whenever I'm going to do a change, that's going to be first deployed as my canary. So let's try that. So for demonstration purpose, I already have a faulty container. So here I'm going to do that. Its tag is just faulty. So this is a change. I'm changing the Docker image of my deployment. This is similar to what change management you'd be already doing. Updating your new release, releasing a new model. Yeah, as this happens, Helm would think that the deployment is successful, but it'll actually not be applied yet. This would trigger a candidate deployment. It's going to first, now at this stage, if I go and look at my deployment, you're able to see we have 2 deployments, right? And test app still doesn't have any metric because now these changes are going to be first deployed here. So this is going to take a couple of minutes to deploy. You can again see the status from here. Yeah, so new revision detected. It's scaling up the deployment. That essentially means it's setting up the canary. So now the canary is set up. Right now, we can see that all the requests are passing. The next step it's going to do is it will initiate the load tester to start generating traffic. So we've configured it at around 100 or 200 RPS. And the test app is purposefully has faulty code. In your case, it could be definitely some potential problem in the way you've configured the routing or your network layer or any part of your model which is getting slower or starts generating unnecessary errors, or maybe it connects with different APIs and data source and that's not working correctly. So let's see, that is updated. And we can also describe the canary object. As you can see now, it is first starting with 5%. So it's going to put 5% traffic on my canary and 95% on my test app. We can also see when the traffic configuration is applied. So you can see that traffic weight split has already happened, right? Now all it has to do is initiate the load tester to generate test load. Practically in your case, you would have your production application, so you will not be using the load tester. It's only for demonstration purpose. So still waiting for the load generator to start. Okay, so the load generator is kicked in. We can see that the RPS has gone up for the test app, and it has also gone up for the primary. So this is the canary zipper, and we can see, like I said, it's faulty code, so the success rate is far lower for my candidate. And now what the hybrid KDS verification is going to do is going to figure this thing out, and it's going to, and this is not the only fault, it might have other problems as well, but it's going to detect that it's a faulty deployment, and it's going to roll back. So there's like a small subset of your traffic or your customers or your end users experiencing errors, right? So this highly impacts, this highly reduces the impacts of the actual downtime. Normally, if you had deployed this code to all of your users, it would have, you would be affecting 100%, but right now it's just 5%. And we can also see what's happening at the candidate deployment. So as you can see, it has already halted the deployment because of an error, and soon this is going to be deleted. And it's again going to go from 95.5 to again 0.100 because it's going to roll back the deployment. Okay, quickly refresh. And if I go to traffic split, it went up to 10%. So it did not fail at 5% traffic. So this is also very cool. It failed actually at 10% traffic, right? And now it's going to halt and roll back. So while the rollback is in process, we can see the details on the cluster page. So here's the deployment history. And if I go down, it shows me that the error rate was abnormal for the canary compared to 0 because, yeah, in our case, the primary has 0 errors. In practice, it will have some errors. And this is now metric validation. Similar to this, even more interesting is log validation. So log validation happens when your all metrics check out. There are no HTTP errors, but there are some new errors introduced due to some problem in your model, right? It could be normally your model performance accuracy could be detected via the normal metrics. In case you encounter, maybe some errors which are not detected in those metrics, there are a lot of cases when that happens. Those will be seen here, and as soon as it sees any abnormal errors, or in some case there was a known error, it was, let's say, 10 earlier, but now it is increased to 80, right? So that's a change in distribution. So that also signifies that there is some problem with my current model, right? So that's also another reason for the application to be rolled back, and the developers, data scientists, ML engineers can all go and validate this thing at their own pace rather than having to firefight the production incident. Another very cool thing here is, let's say if maybe this might not really be an error, right? Or it might be a new error introduced, but you're able to tolerate this error. It's a known issue. So in that case, you can just add that to the knowledge pattern. And what that does is, it will automatically, ignore all of these similar errors going forward, right? Anything similar to this gets ignored. Right, now coming back to our deployment, as you can see now, this is 0, 100% traffic is going to our primary. And now if you go to the traffic split, it's again 0, 100. So it has rolled back. The recovery is super fast, very minimal customer impact, and we're able to detect it and take action immediately. So no human effort involved, and it is super simple to operate. So I hope this gives you an insight on how you can reliably verify your applications at scale and make your deployment super simple for everybody. So concluding from the demo, what we're able to see is we're able to take the complexities of sanity of an ML application and highly simplify that It's fully automated. I did not have to do anything manual. There was no monitoring rules or log registers required for me to write either in the beginning or maintain that as I do my deployments or as I develop my applications. It automatically figures out any performance regressions in my machine learning models. I don't have to have a separate tool, and it's all easily available on the dashboard, and it fails automatically when those things fail. And all of the complexities of Kubernetes is abstracted away from the user. The whole demo was about 10 minutes. None of that was forwarded. So it is super simple to get started. You can follow the documentation and set it up on your own cluster at your own pace. So that highly simplifies the overall setup. Yep, thank you. That's it for today. And you can reach us both at the following emails on the screen. And now we're all open for questions.
So we have a few questions coming in post your talk, and I thought I'll pick the few anonymous ones because I don't think I can get them on the screen. So how do you compare what you've just shown with, what are the other alternatives, right? So I think one of the questions that people will always have is, what are the alternatives, and kind of what is a good use case for doing this, and is there time when you should not be using, hybrid K8s?
Yeah. Okay, I'll take that. So hybrid K8s can be, used by anyone who's trying to make progressive deployments of applications. By progressive deployments, I mean, blue-green deployments, canary deployments. And it generally, so talking about the alternatives, it generally takes 6+ months of initial development to set up those pipelines and channel for progressive deployments, and then a continuous maintenance of those scripts. So generally what happens is whenever you're deploying, the DevOps engineer or MLOps engineer, they'll be sitting at night trying to deploy the application monitor, right? And it takes manual effort. If you don't go by manual effort, then you will be writing some automated scripts in which you'll be writing rules that your error rate for this application should be lying between this and this range. Your latency should be lying in this range. So we are removing all that. So definitely there are alternatives of doing it, but
I'll push you a bit on that. What are the alternatives? I know you're really hesitant to, but like what are something that people can really look at?
Yeah, you can definitely try writing those custom scripts for each application.
Okay.
And it will but cost you much because you'll be spending that time maintaining those applications.
Okay.
Yeah.
Can this be, Sarjan has a question, and I think we're out of time, so I'll just get you to answer that. And maybe there are a few more questions that you can just answer on the Q&A chat. So can this setup be used for A/B tests also? Or is this only for deployments? Like, are there other use cases where this can be extended to?
Yep.
Yeah, I'll take that. So yes, it can be used for A/B test. The typical difference between something like progressive deployment versus A/B test would be the duration of deployment. So we can definitely increase that further. But something as a limitation that we would have while doing something like an A/B test is it's mostly focused on your backend application, right? It's not aware of the front end. So visual changes, your funnel, your drop rate, all of those will not be captured. This is specifically for verifying latency, verifying correctness, verifying performance, those kind of things, errors.
Got it. Okay, so it's probably not right now an ideal case for using this for that purpose. Makes sense.